Welcome to Data Engineers Lunch number 106. Don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. Today, we will be covering designing an analytics pipeline with BigQuery and dbt. And after reviewing the slides, I can tell you there'll be a little bit of Terraform in here about how to set up your infrastructure as well. With Seth Taylor, a senior data analyst who's here to give us this talk. The co-organizers for this event are Rahul and myself. If you are interested in being a co-organizer and want to help get speakers for this event, drop me an email. You can email us at marketing@anant.us or at my email on the previous page. If you yourself are interested in giving a data engineer's lunch, please reach out to me. We're always excited to find new speakers. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is made up of a lot of different groups, generally centered around data, and you can find out more about all of these groups and events at datacommunitydc.org. Here at Data Engineers Lunch, we cover all things that talk or play with data, from production to development. We're here to help you with ingress, egress, ETL, reverse ETL, infrastructure, and all things data engineering and data ops. If there's anybody new that would like to say hi, what brought you here, or what you hope to get out of this, please put something in the YouTube chat. And don't forget to like and subscribe. Turn on the notification bell. A few group rules. If you have a question, ask it. I talked to Seth, and he wanted us to, if there are some questions, he's willing to have us interrupt him. So please post them in the YouTube chat, and I will unmute and ask Seth if it's a timing critical question. Thanks. Please always be polite and courteous and share what you know. This is a community, so please, if you have something interesting to share, you hear something in Seth's talk that sparks something for you, post it in the YouTube chat. Thanks to our sponsors, but before our sponsors, here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. We work all things data engineering, and we have a pretty exciting generative LLM shop going as well. Thanks to all of our sponsors, and thanks to our institutional sponsors as well. George Washington University will occasionally provide venue space. If anyone has job offers, is looking for a job, please drop links. We'll get them, we'll help you promote those. If anybody has any meetups, hackathons, classes, or conferences that you would like to promote, please drop those in the YouTube chat as well. We have a sister lunch, Cassandra Lunch, which meets Thursdays. We have a Cassandra Lunch scheduled for later in the month, actually on Leap Day. So get ready for our first Cassandra Lunch of the year. All of our videos are available on YouTube, starting with Cassandra Lunch 10 and Data. I think we go all the way back to Data Engineers Lunch 1. Finally, if you are interested in downloading our runbook, you can learn a little about how to use Terraform and Ansible to install Cassandra on AWS and Azure. So I'm going to stop here. Thank you to Seth for joining our talk. We're really excited to hear about your presentation. Take it away.
Great, thanks everybody. Thanks for joining me. As Nick said, my name is Seth Taylor. I'm a senior data analyst at Verite Educational Services. We're a small education consulting shop where I am all things data. And coming in, I realized that, hey, I need to learn a lot more about, setting up data pipelines and data engineering. In my past roles have been in government, and so a lot of that was kind of like done for me, and I got to focus solely on analytics. But here I'm having to do solutions design as well. So decided to learn through doing, build a personal project. And in that, I have been working to design an analytics pipeline with dbt and BigQuery, but also with Terraform and Python and Prefect. I'll go through all of that today. And So just a quick agenda. Going to go over a project overview, and then a tech stack and like a very high level architecture diagram. I'll walk through the pipeline and give some code examples. And then there's a data visualization at the end. Not the main goal of the project, but always good to, have something to show. And then some lessons I learned through putting this together, as well as some time for QA and feedback. If you have questions throughout the process, as Nick said, please ask. So just a quick overview. So like I said, this was a personal project to just learn more about kind of the modern data stack and data technologies. The goal of the project was building a batch ELT pipeline to gather tennis match level data for both the ATP tour, which is like the main tennis tour, as well as challengers, which are you can kind of think of as like the up and comers, and transform it to, for visualization. I really like tennis, so always good to pick a project that has some personal interest to you. But also, I think like tennis analytics is pretty limited in terms of public availability. Obviously, the tour puts some information out, but it's really usually focused on the current season and the current players. I was kind of interested in the whole spectrum of tennis. So for anybody who likes tennis, this goes all the way back, even before the Open era. I believe the earliest data that I had is like 1964. So it's 1964 through the end of this most recent season in 2023. The data source is from a community-driven public repository for tennis match level data. There's also point level data, but it's not quite as robust. Credit to that goes to a guy named Jeff Sackman, who does a ton of tennis analytics on his own, and also manages that repository. And that repo is updated roughly on a weekly basis during the season, and then isn't really updated between December and January because there aren't any matches. So high-level tech stack, Python and pandas to do the extraction and loading. And that loads from the raw data in the repository to a data lake and a data warehouse. That data lake and data warehouse is hosted on Google Platform using storage bucket for the data lake, and BigQuery is the warehouse. I use Terraform to create the GCP infrastructure as code. Prefect orchestrates and monitors the extraction and loading logic. DBT is kind of where the meat of the project is, really. That's all the staging and transformation of the data from raw to stage to production. And then Looker Studio is creating the analytics dashboard, largely because it's free, not because I love Looker Studio at all. Here's a really high-level diagram for the architecture. So you have the raw data that's EL'd with Python and pandas, as I mentioned, with Prefect orchestrating it. And then that is dumped into Google Cloud infrastructure that has been produced with Terraform. Cloud storage is really used as like a long-term storage container, not as like an intermediate place to store before transformation. Just in case I need to do any like reloads in the future, or if the repository goes down, it would be good to maintain it, and it's really cheap. And then BigQuery is the data warehouse, transformation with DBT, like I said, and it's sped out in Looker Studio. So infrastructure is code. What is it? Why would you do it? I was new to that concept when I started this project. Basically, Terraform is provided by HashiCorp, and it's just one of many like infrastructure as code languages, but I think it's the most common these days as far as open source ones go. So it's a declarative tool, and it helps you govern and create cloud infrastructure as code. So basically, you describe your desired end state, and then Terraform builds it for you. Some benefits that come with that are improved collaboration and reproducibility. You get version control. You can store it in Git or GitHub or any Git provider, and then you can run it. It produces the infrastructure, and you can monitor it that way. It allows you to reuse infrastructure creation logic across multiple deployments. Terraform is kind of constructed into modules, and you can use variables and things like that that allow you to reuse modules over and over. So if you have to create like a lot of BigQuery datasets or a lot of buckets, then you can use a module and you use variables to create as many as you want. Resources being created and the dependencies between resources are easily understood, in my opinion. You kind of see what you're writing it in plain language, and then you're going to see what changes before you execute it. When you run your Terraform, it gives you like a plan, and that plan details what resources will be created, which ones are going to be changed in some way, and it details what the change will be. And then if any get destroyed, it'll also tell you what gets destroyed. Terraform can be run kind of standalone through the CLI, or it can be governed by CI/CD pipelines to ensure that your infrastructure is deployed in line with your development process. I didn't do that for this project because this is such like a beginner project and I was just learning. Wasn't really familiar with CI/CD at the time, but there's some projects I'm developing right now where I do integrate it with CI/CD. So here's some example of Terraform code. I have two TF files here. One is main and one is variables. So in main, you have some pretty simple stuff. You have your version and where the backend is stored. Terraform basically creates like a state, and that state details, like it says, what state your infrastructure is actually in. You can either store that locally, or as the comment notes here, you can store it in like a GCS bucket, or if you're using a different provider like AWS, you could store it in S3 or something like that. That's good if you want to like collaborate with other people, or if you aren't just developing it on like one local environment. You have your provider, so that's just Google, and then you describe what your resources want to be. So you can see here we have like several resources. We have a data lake bucket. And that has a bunch of variables in it, which I'll explain in a second. But basically, you describe exactly what the bucket wants to do. So we want versioning enabled. We want it to be in a certain region. We have a lifecycle rule here where we delete it after 30 days. That's just because this is a personal project. You can set whatever lifecycle rule you want. So whether that's transitioning it into some kind of archive storage format or less frequently accessed format for cost savings. And then we also have data warehouse buckets. So I have several. I've just given one example here, but you just kind of describe what the bucket you want is in plain language. And then the variables kind of details the description and default statements for each of them. So it describes your region. All my stuff is in US East 1, the storage class for the data lake bucket, and then the names for the 3 BigQuery data sets I'm using. So a raw one called tennis data, a staging data set where those intermediate models go in, and then a production data set. So extraction and loading. EL for this project was really pretty simple. So it uses Python and pandas just to pull data from the repository online, downloads it as a CSV, applies some really minor transformation, really just datetime conversions, and then loads to the target destination. One script going to the data lake and one to the data warehouse. You could chain those together, and I've seen that in other projects, like go to the data lake, then download the bucket files and then send them to the warehouse. But I didn't really see a reason to do that in this case, so would be interested to hear how that works in like a production setting from anybody on the call. Prefect is primarily used as a scheduler in my case, but also helps parameterize the EL script and helps manage credentials and connections. Prefect is like way more powerful than the way in which I'm using it, and can help support like detailed observability, automation, event-driven workflows, logging and alerts. You can send alerts to Slack, email, etc. But I'm just using it in a pretty simple way. So here's just a quick example of the code which loads to BigQuery. You can see it is, in fact, very simple. So, first we define a few functions. We have a fetch function, which is just simply reads from a dataset URL, reads it as a CSV using pandas. Cleaning, like I said, is just converting the attorney date variable to a datetime format. I initially tried to skip this and had some issues with typing later on, so I gave up and did it here. And then it writes the data to a BigQuery table. Prefect supports these things called blocks. You can see on line 23, there's a GCP credential block. So basically, Prefect is managing my credentials for me for GCP. You create a service account, and you create a key for it, and then you give Prefect the JSON for it, and then it manages the credentials for you. You don't have to worry about having it as an environment variable or storing it in your repo and then adding it to your gitignore or whatever to avoid exposing it. It just kind of does it for you, which is really nice. And there are lots of different types of blocks. That's just the one I'm using. And the way Prefect works is it's pretty simple. You just have these little decorators. So you can see there's a flow decorator on like line 33 and 43. That's like the main entry point for the function, the main flow. And then flows are subdivided into tasks. So on line 7, 13, and 19, you have these tasks. And tasks just help you get more observability into your flow as far as I understand it. When you run a flow, you can see how your flow ran, but then also how your tasks ran. So you can see like points of failure, you can log based on tasks, things like that. And you can see here I've kind of parameterized this flow. So within the line 43 to 48, we've divided up the flow into tour, like subgroup being ATP versus challengers, the years, and then the destination table. So ATP data gets sent to the ATP table. You can run it for certain years. You can run it for certain tours. The default here is 2023. Basically, I do like one big pull of all the data ever, and then if I wanted to update, I would just run 2023 repeatedly. And we can flip over and take a look at the Prefect Cloud UI. So unfortunately, I kind of stupidly had this, I was using local runners and I had a virtual environment set up, and then I accidentally deleted that virtual environment. So I don't have all the history for the flows, but I do have some from the testing I was doing like when I initially did this. So you can see here, you have your flows, and then you have something called a deployment. And a deployment is basically, you tell Prefect where to find the script and what your default parameters are. And then it creates this deployment for you in which you can like further define schedule and a bunch of other stuff. So if you click in, you can see over here on the right, you have like your entry point in your path. So that tells Prefect where to find the actual script. I have it just finding it locally. As you can see, like it looks in my GitHub repo folder and then grabs the script. But you can host deployments on Docker too, so you don't have to have it only running locally. And then if you want to go up here and you can try and run it, and you can go to custom run, you can see that you can define the parameters that are inserted. So Prefect, based on what you put in the flow, knows that you're looking for tour, knows that you're looking for subgroup, and knows that you're looking for years. These are all optional, and they have defaults. So by default, it runs for ATP for year 2023.
Hey, Seth, we had a question pop up
Yeah.
in the chat. Question was about where are you running the CI/CD code? I think I heard you mention something about this at the beginning, but I just wanted to address it here.
Yeah, absolutely. So I didn't have CI/CD in this project because I honestly just didn't know a lot about how that worked. For other projects, I pretty much just use GitHub Actions. And for Terraform, there are both GitHub Actions, like little modules that have been written by HashiCorp for Terraform. And then there are also like some community modules, which are really great. Like for another project, I'm running a GitHub action that it runs Terraform plan every time on a pull request to main, and then sticks that in a comment on the pull request. So before executing, I can like look at what's going to change. And then when I execute, when I merge to main, like it triggers the actual application of the Terraform code.
Thank
Does
you,
that
Seth.
kind of explain what they're getting at?
Yeah, that's great. Akil, I would add that here at Anant, we have also had very good success with GitHub Actions. So I can put some vouch on that as well.
Great.
Okay, thanks. Carry on, Seth.
Yeah, of course. Yeah, so that's like, you can see here also we have blocks. So I'm not going to click into the credentials block because I really don't want to publicly expose my credentials. But basically, like you can define these blocks, and there's one for every major cloud provider that you could think of, as well as non-cloud providers. Like here I have a bucket block, which basically just defines where should my code look for the GCS bucket, and then the credentials are associated to this block, so it has the proper credentials when it goes to, write to the bucket or read from the bucket, which is really nice. As you can see here, you can also have like event-driven workflows, you can automate, etc. I didn't really use that, and it's not set up for this little testing environment anyways. But if you look here, this is not mine. This is one of the Prefect public FAQ documents. This is what it would look like in kind of like a production setting according to Prefect. You can look at all your flow runs, you can look at your tasks, how many are completed versus failed, all the events, your worker pools, and then you can check out exactly what happened in a failed run as well. So transformation, that's really kind of where the focus for me was in this project. And I use dbt. So dbt is data build tool. It's an open source data transformation tool. It uses SQL as the primary driver for transformation in the data warehouse or your data lake or lakehouse or however you want to do it. And it kind of helps you apply software engineering practices to analytics code development, which is really helpful for me because software engineering is not my background. It's not kind of the way I natively think. And so having a structure that kind of helps me implement best practices natively is very helpful for me. So dbt connects to a Git repository for version control and collaboration. It kind of abstracts away boilerplate CRUD statements and supports modularity of SQL code, which we'll see in a minute. It natively supports testing and documentation for your models, which is really important. And then it manages dependencies between your models, tracks lineage of your data, and you can either run your models on a schedule or integrate it with CI/CD. Again, didn't do CI/CD for this project. I just ran it on a schedule, and that's kind of how I handled it. So we can flip over to my dbt project. So I was running this on dbt Cloud, which is free for one user for small use cases. You get one project. dbt Core is the open source CLI version of dbt, and it has almost all of the features of Cloud as far as I can tell. You just have to kind of run it, host it yourself. So dbt is organized into projects. So this is like the tennis analytics project. And setting up your project is really simple. So you connect it to a Git repository. So you can see here, this is my tennis analytics pipeline repository. You create a connection to BigQuery, which is as simple as setting up a service account and giving it the JSON for your key. And then if you have dbt in a subdirectory, you can specify a subdirectory. Documentation is associated with specific jobs, which we'll see later. When you put something into production, it's done in jobs, and then documentation is generated based on your job. And Cloud comes with like a cloud native IDE. So you can see here, once it loads, all right, get the spinny wheel. Sorry, internet is a bit slow today, I guess. Yeah, so we have our project structure here. So dbt is a subfolder, and it kind of auto generates.
Hey, Seth.
Yeah.
Do you think you could potentially zoom in a little bit? The text is a little hard to read at this resolution. Thank you.
How about that?
Much better.
Great. So yeah, you have your dbt repository right here, which comes pre-populated with various things. All dbt projects start with your project YAML. So this kind of just defines the basic configuration for your project. So you give it a name. This is all pre-specified, but you could change the folder names if you wanted to. So models go in models, tests go in tests, etc. You have some targets for certain things, which, are really like an internal thing for dbt, so I didn't really mess with it. And then you configure basic configuration for your models. So as it says here, default materialization is a view, but I wanted my core models to be a table. So I specified my core models will be output as a table instead of a view. You can do a lot more in this YAML. This is a really simple use case. And then basically you have models, which are all defined as SQL statements, and they start with a schema. So with your schema, you define your source. So it's looking in the BigQuery database I have. The schema is the actual data set it's going to look in. And then we have our tables within that data set. So we have the ATP tour table and the challengers table. Model, I've included documentation here. You don't have to include documentation, but documentation is always a good idea. So you can name your variables, include a description, and include a description of your overall data set. And I do that for a staging one for the ATP tour and a staging model for the challengers tour. DBT also has seeds. So seeds are basically like little tables or little pieces of data that would be helpful to create models in the future that maybe you don't want to store, in a BigQuery data set. In this case, I have the IOC country codes. And I don't want to create a BigQuery table for this. It's, 196 rows of data. So easy enough to have it as a seed. And as you can see with this lineage, it's used to create a country's dimension table, and then that flows into a fact table later. So staging models are created, and then we also have core models. So my core models are kind of two-stage. So the first real core model I create is a fact matches table. And you can see here, the way you specify models is kind of a mix of just a straight up select SQL statement and then Genjo, which is this kind of templating language. So I use a couple CTEs here to just grab the staging data. So I select everything from staging, and then I give a flag for what tour it's from. And then this is from reference, and it references the model. So it knows where to go and get the data from. You don't have to name the specific table that is created in BigQuery. And that just helps maintain referential integrity and keeps things simple. We union all the tables together, and then we have our country dimension table. We do a bunch of select statements here to get all the tables. And then we join the dimension onto the table to give us our countries in addition to the country code. And as you can see here in the lineage at the bottom, we have our staging tables that flow into fact matches. I then create a players matches table. So player matches is a table that reunions the table to change the grain. So it changes the grain from a match level to like a player match level. Fact matches is a table where every row is a match and it includes data on winners and losers, but that complicates analysis when you want to look at like player specific statistics. So this just like reunions the tables together to create a table where every row is a player and their performance for a specific match. And you can see here, I create a select statement for all the winner data. And then I create a select statement for all the loser data, and I union those two together to create the player matches table. And then I have some specific tables for interesting statistics I wanted to look at. So we have things like bagels by year. For anybody who doesn't follow tennis, a bagel is when you beat somebody in a set 6-0. The 0 looks like a bagel. Pretty funny and also like pretty hard to do. So just a really simple statement to find all the bagels for a specific player for a specific year. We also have deciding set win percentage. So like deciding set, if you have a best of 3 or a best of 5, what percentage of sets did you win where it was the last set in a match? So like you could have won, you could have lost, essentially like a high pressure situation kind of analysis. So we use like two CTEs here. First, we want to look at players that only have 25 or more matches across their career. We don't want somebody who had one tough match and like they have 100%. Not really that interesting. Then we actually have the logic for creating the deciding set matches. So some case swing statements about when it's best of 3 or best of 5, and then looking for when the essentially counting spaces, like scores come in a specific format. So you're counting how many spaces there are to determine how many sets there were. And we don't want it to be a best of 1, obviously. And we don't want it to be a match where somebody retired. Retired means they left on an injury. So that's kind of the core of the actual creation logic for this analysis. Nowhere in here has there ever been like a create table statement or an insert or an update statement. dbt does all that for you. So when you create selections, it is automatically doing all that creation logic. dbt also supports some time-saving things through modularity using macros. So here is a situation where there's a bunch of different ways someone can enter a tournament. They can enter a tournament through like being a wild card, through a qualifier, etc. You don't want to write this case when statement, 10 times, much less write it 100 times if you had, a much larger analysis. So basically you can create this template and then insert it into the actual models, and it runs this case when statement every time for you with just like one line of code. Yeah, and then tests. Tests are really important. So there are built-in tests with dbt. Built-in tests include things like referential integrity. It includes testing for uniqueness of uniqueness of like unique IDs. And then you can also define your own tests. So like this is a test that I wrote to assert that certain values aren't negative. So I didn't want things like number of serves to have negative values because that doesn't make any sense. And so you can use this test to ensure that your model doesn't have any of that. So that's basically the way you set up a DBT project. Notably, this all has to happen in the develop branch at minimum. You can obviously create feature branches or sub branches if you want to, but DBT Cloud at least does not let you commit directly to main for your development. You have to have a pull request to go to main, and then you can deploy to production from there. When you want to deploy, you can go here and you can see I have some failed jobs and I have some successful jobs. So a job is basically you tell DBT to run a specific command. So I have this DBT build command. DBT build means do everything. Test my model, build all the dependencies for my model, and then actually build the models and put them into BigQuery. So you can see I have like some completed and some errored out ones here. Ran some today and forgot I let my billing account expire, so they didn't succeed. But we can take a look at like a successful run. And DBT does a few things. First, it's going to clone the repository. It's going to determine that BigQuery is actually connected. It's going to build dependencies. So in this case, I'm using a DBT utils package, which is created by DBT itself. That includes super helpful things like all those internal tests, some expanded tests beyond that. And then it also helps you do things like creating surrogate keys, where you can just concatenate certain variables together in really simple template language to create unique keys. It's going to invoke whatever build you tell it to. So in this case, the command is just a simple dbt build where variables is test run equals false. I have some really simple logic in the staging models where if it's a test run, which it's defaulted to true for a test run, then it limits it to like the first 100 rows, just so I'm not querying my entire data set every time when I'm building and testing these staging models. You can see here we have some warnings. So these warnings are based on the tests that got run. And we can see that there are apparently two rows where the accepted range of data is not correct. So that means there are two rows somewhere in my data set that don't have that have negative values, which isn't good, but I set it to warn. You can make a job fail based on a test, or you can warn based on a test. In this case, I just made it to warn. We also apparently have about 1,900 unique match IDs in the fact matches table that are not actually unique. So I really wasn't able to find the source of this issue, so I eventually set it to warn and kind of moved on. But I think it has something to do with the fact that a match ID, as I constructed it, is based on a match number and a tourney date. And I assume those things would be unique, because on a day for a specific match number, you would assume that would be unique. But presumably there are some match numbers that are duplicated somewhere, and that is causing this error. I didn't solve this, but in a real production setting, you definitely want to solve this problem. And then after it runs this build and it succeeds, so you're completed with 2 warnings, it's going to generate documentation. So it generates documentation based on all those descriptions we had in the YAML files. And if you go up here, we can view that documentation. And you can see here it has just a very specific project documentation, so you can go and look at the models. And here's all of our documentation for the staging ATP tour model. So it's giving us the column name, its type, and then its description. It's also going to tell us if it has any constraints or tests. So we applied our tests to our core model. So right here, you can see that we have a test for not null and unique, which we saw the warning for. So I didn't go through this project and document every single thing. I was really just kind of testing it out. In a real setting, you probably want to have descriptions for all your critical data. And after all that happens, sorry, I have to move this. We can look at what it looks like in BigQuery. So you can see here we have our tennis data, raw data. We have all our staging tables. And if you look here at storage info, you can see how the is_test_run variable impacted it. So even though this is our fact table for data that is by default, I want to say how many, it's 50 megabytes for just less than half of the data. The is_test_run limited it to just 108 rows, which is kilobytes. So we're saving a lot of data there. And then in the production setting, we can see that these models get rebuilt, and we have our much bigger table, like total logical bytes 136, and we see there's almost 402,000 rows. And these models get rebuilt. I assume there is some way in dbt to limit these staging tables from being recreated in your production setting. I did not figure that out. So if anybody knows, let me know. And that is it for the way I implemented dbt. dbt seems really powerful to me. You can include Python in your dbt as well. So if you need some specific like Python logic that SQL can't handle, you can include it there. And then, as I mentioned, you can run your job on a schedule, or you can run it via CI/CD. So when there's like a pull request to main, you can trigger your job to run. There's probably also some like other event-driven way to do things, but that's what I'm aware of.
I just wanted to add something here that was mentioned in the chat about dbt, specifically dbt macros. You can have multiple analysts or engineers and reduce the amount of duplication where people are doing slightly different things everywhere. I think this basically means like you can have a ton of people working on the same data without them having to sort of, redo everything on their own. And that's a very powerful functionality.
Yeah, that totally makes sense to me. Yeah, like it saved me a bunch of time just writing those macros once. I didn't have to rewrite it for everyone. So if you had like a whole team working on 300,000 models versus 18 models, like it would save you exponentially more time.
Yeah.
Great. So here we can see the lineage. dbt also tracks your lineage, which you saw at the bottom of the screen. This is just the total lineage for all of my data. So we've got our staging source data sets, which is pulling from our BigQuery raw data table. We have our seed for IOC codes. That builds all of our staging models here. So dimension countries are 2 staging data sets, flows to our fact matches table, and then goes to player matches. And then we have our three final data sets, which look at like specific statistics we're interested in. Obviously, this is not like in a star schema. It's much closer to like a one big table model. If you were running this in a production setting, I could see why you'd want to do star schema, because you probably don't want to update player names or like their country of who they represent or things like that for, if you had massive amounts of data. But in this case, it seemed, simple enough to do like a one big table approach. And data visualization. So final data models are visualized in a Looker Studio dashboard. This wasn't like the core thing I was looking to do in this project, but just kind of a way to test and showcase what I did. So the visualizations really just examine tournament performance by player, country, and then also over time. And it includes some breakdowns by ATP Tour and Challengers Tour. So let me just flip over to the dashboard. So this is Looker Studio, so not the prettiest thing in the world, but basically we have a map here based on player country. We have some information about the total number of tournaments, and then a split based on tournament wins within the ATP and tournament wins within challengers. This is all-time data. So you can see here, Jimmy Connors has the most wins of all time, according to this data set. And then we have some usual suspects here: Federer, Djokovic, Nadal, Lendl, etc. People who had really long careers and were really dominant. We can also look at country. So if we want to look at like all the Spanish players of all time, whoever had the most wins, surprise, it's Rafa. And you can also look at challengers. So some people I would never have really known of. And as you can see, challengers is much more evenly distributed. People who are really good in challengers tend to move up to the main tour. So you have lots of people winning tournaments. There hasn't been such dominance as in the ATP for the last like 20 years. You can also filter by date. So if we want to look just within like the last year, apply that. This is all the Spanish players. Let me see if I can get that to be on. Sorry, just going to reset it. And then flip to the last year. Yeah, so now we can see performance last year. Obviously, Djokovic had a great season in 2023. So did Alcaraz and Medvedev. We also see some players in the ATP Tour. So maybe these are people to look at as up-and-comers. Probably not Andy Murray. Obviously, he is still having a rough time coming back to the tour, as much as I love him. But yeah, like these are players you might want to watch out for in the coming years. A lot of these guys are younger guys. We also have tournament performance as a round-based breakdown. So you can't win every tournament, obviously. Making the quarterfinals, semifinals, and finals is a pretty big accomplishment. So we can see, over time who collectively made the most number of those rounds. Again, some of the same usual suspects for all time. And if we look at the last year, we can see who performed best in this past year. So notably, Djokovic not the top here because he didn't play that many tournaments. But we can kind of see who had the consistently best performance across the year. And then again, people making quarter semis and finals in the Challengers Tour. And then we have players with the most bagels. This is bagels as match winners. So when they won, how many bagels did they collectively have? And when they lost the match, how many bagels did they collectively had? Kind of has to hurt to beat somebody 6-0 and then lose the match. And again, we can look at date ranges as well if we want. And then also just have like a little data dictionary. So anybody looking at it who doesn't know tennis kind of has a sense of what it is. So defining a bagel, defining a round, etc. This is just some slides for posterity. So lessons learned. I think I'd consider using serverless functions to run the EL logic. The EL logic is like really simple, and I didn't really feel like I got all the power out of an orchestrator that like Prefect can bring you. Prefect was like beautifully simple. I had like tried to learn Airflow in the past, and it was really confusing. And so Prefect just having the decorator was really nice. But again, I wasn't using event-driven workflows or orchestrating complex flows together. So like a serverless function could have done the same thing. And then if I'm not using serverless, I would move the EL logic off local runners to like a cloud server or something like that, just to have a little bit more reliability. if I shut my laptop and I forget about it, or if my laptop breaks, I don't have to worry about losing, my runs. Later, I learned DBT models can actually be managed and executed by Prefect or other orchestrators, which would be useful, like tying all your models together. Like I could trigger a DBT model based on a successful Prefect flow run, which would make sure that my transformation logic isn't divorced from my extraction and loading logic, which I think would be helpful in like a production setting. I'm not sure if you can do it with DBT Cloud, so I would consider using DBT Core instead and just orchestrating with Prefect or another orchestrator. And then I think just as a kind of a workflow thing, I would define my use cases and requirements up front to keep development more bite-sized and manageable. So I kind of approached this project as like I had a high-level idea of what I wanted, and then just kind of developed from there. And sometimes it got a little unwieldy to be like, okay, today I'm going to develop all my transformation logic. Some of my other projects I've been running, I've kind of used GitHub issues to track individual requirements in a much more bite-sized manner. So like, okay, I'm going to create the Terraform for the BigQuery datasets, or I'm going to create the Terraform in general. And then creating a feature branch for each of those requirements and developing them one at a time has helped me kind of structure my projects a little bit more. So yeah, that's the presentation. Open to QA, also open to feedback. Obviously, this was a learning experience for me. So if anyone in the field has feedback, how does it differ from a production pipeline? Or if you just have thoughts in general, would be great.
Thank you, Seth. There was one question in the chat, which we'll definitely answer, but I wanted to give you a run at as well. What did you use for learning DBT? So yeah.
Yeah, so there's a really great free course online. It's called Data Engineering Zoom Camp. That's also why I chose Prefect, because that's what they were teaching at the time. So it's like a 6-week course. You can either do it as a cohort or self-paced. It's, YouTube videos and practical learning, and that's what I use to learn DBT. Definitely could see why it could be intimidating if you just came into it on your own. But then also just reading documentation, a little chat GPT usage here and there to figure out answers, that sort of stuff.
Yeah, thank you. So I'm not much of a tennis fan, but I'm a much bigger basketball fan. So I was wondering if something like Prefect could be used. And let's think about this in terms of like a line that's moving. You're obviously part of the grand tradition of analytics in sports.
Yeah.
And that is something that obviously has a big correlation with sports betting. A lot of people working in analytics end up eventually working for the line makers, who are essentially setting the betting lines. So I was wondering if something like Prefect, if you could set it to like essentially pick up data during the match. So pick up data during the match so that you could essentially do live updates on whether a person should be expected to win, for example, at a certain point during the match.
Yeah, I believe so. So I assume if there's like an API, or even if you set up like a web scraper or something, you could do that. I don't know too much about it. I know Prefect does have event-driven things, so presumably you could either run it maybe with like a stream as your data source, which since it's just a decorator for Python, I assume streaming is a use case for it. Or have it just be like a near real-time batch, like every second or every 10 seconds or whatever your API is set to update at. You could definitely do that with Prefect as far as I'm aware. That's actually the idea I had for this. Like originally was like, oh, can I create like a machine learning algorithm that predicts who is likely to win the match? And then I was like, okay, maybe I'll start with a smaller use case first with some simple analytics, and then I'll maybe approach that later on.
Oh, we just got a question from Kit in the chat. Did you have a vision of what you wanted with the analytics dashboard and build from there? Wondering what your conceptual starting point was. I think we just sort of addressed that a little bit.
Yeah, great question. Yeah, so like you said, my conceptual starting point was like, okay, what factors go into someone winning a match? And then I kind of started from there and then scoped back to, okay, let's like look at who has been winning matches. So that's where I started. But yeah, I think to that point, like taking some time to define use cases for end users up front, even for a personal project, could have been really helpful. Like, how would a user want to use this dashboard? And then define the models I would need to populate that visualization from there.
Interesting. Okay. Thank you so much for your time. I do not believe we have any additional questions, but I just want to thank you for presenting for us here. And this was a really great talk. I think the sort of way that you walked us through sort of each of these components was really helpful. And I just want to, again, thank you.
Great, I'm glad. Yeah, on the last slide here, I have like the link to the repo and the data source, as well as some contact info. If anybody has questions later, please feel free to reach out. I'm happy to chat about it. And if, like I said, if you have any feedback for me, like please reach out. Definitely always interested in learning more.
Thanks so much. The repo has been posted in the YouTube chat, and I will be posting the this slideshow in the description after the end of the video. So
Awesome.
thank you again to everyone. Really enjoyed the session. We have some more data engineers lunches planned for later in the month, and we'll see you next time. Thank you, everyone. Bye for now.
Thanks, everyone.
Okay. The stream is ended. Let me turn
Cool.
off the